السلام عليكم ورحمة الله وبركاته. النهارده هنتكلم عن reactions. Part 1 calculating reactions. First example, like what we talked before about, we have three equations, three principal equations, sigma fx, sigma f equals 0, sigma fy equals 0, and sigma moment equals 0. So when we have this shape, applying the equations, first we need to resolve the force at C into horizontal and vertical components. The sigma fx equals 0, so simply it is 6, which is 10 times 3 over 5 minus ax, so ax equals 6. Sigma moment about a equals 0, so 8 times 15 minus 10 by equals 0, so by equal 12 kips. Sigma fy equals 0, ay plus by minus 8 equals 0. Therefore, ay equal minus 4 kips. دايما نسأل نفسنا سؤال، هل النتيجة دي لوجيك ولا لا؟ لما تبص للستراكشر ده تعرف انها لوجيك، ان الرياكشن عند واي هيبقى نازل لتحت مش طالع لفوق، لان في كانتليفر على الطرف وفي فورس نازله لتحت، فبالتالي السبورت اللي عند ايه ده عايز يتشد، مش حاسس ان هو بيتضغط، لا ده عايز يتشد، عايز يطلع من مكانه، فعشان كده الرياكشن جه نيجاتيف، جه نازل لتحت مش طالع لفوق. Second example, ده هنا فريم A B C. A is a roller, C is a hinge. The load is part of it. The load is a trapezoidal load, 10 kN per meter at B, 4 kN per meter at C. فطبعا you need to get the equivalent of this trapezoidal load, so you will divide it into a rectangle 4 kN per meter and a triangle. So R1, which is the equivalent force of the rectangle acting at the middle of the rectangle, is 40 kN, 10 times 4, which is 40 kN, while R2 is half of the area of the triangle acting at 2/3 of the triangle from the vertex. So half of the area of triangle is half times 10, which is the distance, times 6, which is the difference between the 10 and the 4. So this is 30 kN. From sigma moment about C, and the best point here to take a moment at is C, in order to have only one unknown. And if you take a moment at A, you will have two unknowns. But if you take a moment at C, you are cancelling two unknowns and you are having only one unknown in the equation. So this is the fastest way to get AY, which is multiplied. So now moment at C, AY is multiplied by 4 minus the R1, which is 40, multiplied by 5, minus R2, which is 30 multiplied by 20 over 3, so AY equal 100 kN. CY, we will calculate it from sigma Fy. So sigma Fy is simply equal 0. So we have the 100, which is the reaction of AY that we have just calculated, plus CY, minus the two forces, the 40 and the 30. So now CY is negative 30, it's going down. And sigma Fx equals 0, Cx is equal to 0, which is making sense because you don't have any horizontal forces. The third example here, we have an intermediate hinge. Again, like what we mentioned before, intermediate hinge means having one additional equation. one intermediate hinge, one additional equation. So we have what we call one conditional equation. The conditional equation here is what? The sigma moment about C equals 0, whether if you look left or right. So you take sigma moment about C and you look either left or right. So sigma moment about C, so my unknowns here are AY, BY, EY, and EX. Of course, sigma moment about C, looking, the easiest way is to look at the side with only one unknown, so which is the right hand side. فبص يمين بس. So sigma m about C equals 0. So I have 24 times 5 minus 10 EY. So EY equal 12 kips. Sigma of x equals 0, EX equals 0 anyways. Sigma moment about A equals 0. So now I got EY. I have EX equals 0. AY is passing by point A, so it's cancelled out. So my only unknown here is BY. So now I have 12 times 15 plus 24 times 20 minus 12 times 25 minus 10 BY. So BY is 36. Finally, sigma Fy equals 0. I have AY. This is my unknown here. BY is 36. Then I have minus 24 and minus 12. And the reaction EY was 12 kips. Was that, so we will substitute the 36 for BY and the 12 for EY. Now we will get AY is equal to minus 12 kips. Again, it's going down, which makes sense because it wants to be pulled up. So it wants to be pulled out and it wants to resist that pull. So it is minus 12 kips. Thank you.